We have a question here which relies on us to use the distance formula between 2 points for our locus. So first of all, let's remember the distance formula. And we know the distance between 2 points is the square root of my 2 points squared and then y2 minus y1 squared. So this, of course, is built on Pythagoras, where we would have had the idea of c squared equals a squared plus b squared, where a is my horizontal distance and b is my vertical distance. And once I take the square root of c, or the square root of both sides, I would have this. Now, my x2 minus x1 is the difference between my two x coordinates, and my y2 minus y1 is the difference between my two y coordinates, which is how this formula is related to Pythagoras. So now let's connect that to my points Q and R. Now my distance from Q to P will be the square root of my P point, which is going to be x minus, and then my Q point, so therefore -1 squared, and the y, the difference between the y's, which will be y minus 2 all squared. So from my point P to Q, that is the distance of my line. For my point R, the distance between my point R and the point P will be, in the same way, x from point P minus the x coordinate, which is 3, plus y minus the y coordinate, which is 1. So here is the distance between my 2 points and that point P. And the question tells you that it's equidistant. So therefore, these two are the same. So QP will equal RP. And therefore, x plus 1 squared, because remember my minus minus becomes a plus y minus 2 all squared will equal x minus 3 squared plus y minus 1 squared. And now I'm going to use my algebra to get this to the equation of a line. So first let's square both sides. Therefore, x plus 1 squared plus y minus 2 squared equals x minus 3 squared plus y minus 1 all squared. Now let's expand all our brackets. So x squared plus 2x plus 1, you'll be able to see here how important it is that you know your expansions for perfect squares. And now let's start collecting some like terms and start simplifying. You'll notice here I have an x squared on the left and the right hand side. So I can get rid of them. And I also have a y squared on the left and the right hand side. So now we know this relationship is going to be linear because we don't have any squared terms anymore. Let's just clean it up so we can work a little bit better with our other terms. So I'll end up on the left hand side now with 2x minus 4y plus 5. And on the right hand side, when I clean it up, that should be a y, I end up with negative 6x minus 2y and then plus 10. Now, of course, to find the equation of a straight line, I want to have it in the form of y equals mx plus c. Remember though, I can also have it in intercept form should I wish. So let's start moving things around and managing it this way. If I have my 2y on the left-hand side, on the right-hand side, I might want to bring that over to the left-hand side, and same with the x's. So I can end up with negative 2y equals Then with my x's, I'll have negative 8x. And then with the constant, that will end up with plus 5, or y equals 4x minus 5 over 2. And there I have the equation in y equals mx plus c, gradient and y-intercept form of the straight line that is equidistant from these 2 points. Of course, if I wanted to, I could represent that in intercept form where I had something x plus something y, something like this, equals a constant. Either way is fine if you're not asked to present it in a certain form.
If you found this video helpful, please subscribe to my channel or like the video.